So we will discuss VLANs today. Before we discuss VLANs, let's analyze or go through the switch, how it works once again. This is the topology we have been using. This is the small network we have been using. So this PC is configured with 10.1.1.1. This is 2, 3, 4. This is a switch with 6 ports, and 4 of them we are using. 2 of them, as you can see, are down. Now, why do you need to use VLAN? Because we want to make sure that a particular set of devices in the LAN is not able to access or communicate with other set of devices. We want to separate logically by software these different computing devices. Generally, what happens is, if what is called a particular PC or computer sends a broadcast traffic, it will be sent to all. It will be sent to all the rest of the computers. And again, when the MAC address table is filled up and its ARP table is all filled up, this PC can access this PC, everyone can access everyone. But we want to restrict that behavior. Think that there are 2 departments in an office. PC1 and PC2 belongs to one particular department. PC3 and PC4 belongs to another department. And we want to make sure that they are not able to access each other. So this is the concept of, this is where we'll use the concept of VLAN. But before that, let's look once again. If I try to, this switch is currently, I have erased the MAC address table here. So let's see, show. Nothing is there. Similarly, all these ARP caches are most probably empty. So if I see ARP, yeah, no, nothing is there. Again, is the, you're starting from 0. Let's try and again go through this. Ping 10.1.1.2. So I want to ping from here to here. When I do it, let's give it only one time. It's successful, and we know what the process is. If I now write ARPA, I have the MAC address and the IP address mapping for PC2. Similarly, PC2 would have learned the MAC and IP address of PC1. Let's do this from here. So now let's see. Let's again look at the, so the switch has learned the MAC addresses of these 2 PCs and in which ports its MAC addresses are. Fast Ethernet 0x1. This is the port, Fast Ethernet 0x1, where it is connected to this PC with this MAC address. Fast Ethernet 1x1, which is this port, it's connected to this PC having this MAC address. But it still does not know the MAC addresses of these 2. So let's now run, let's say, simulation mode. This we are revisiting the previous concepts. So I want to ping. So I will ping from PC3 to PC4. But the MAC address table does not have, the switch does not have any information of the MAC address of these 2 PCs. Let's see what happens then. So as usual, we should see that ARP is first ICMP packet is process is started, but it cannot go on because ARP has to be started. The MAC addresses are not known to this PC. PC3 does not know the MAC address of PC4, so ARP process started. And in the ARP process, there is a flooding message. So what happens? Flooding message, a broadcast message, FFF in the Ethernet layer frame. So it will flood. And then similarly, the thing continues. So we don't want this to happen. If I knew that this PC and this PC were in a particular VLAN, no packet of data, apart from some specific cases where we call management traffic, nothing should be able to, this PC should not be able to send any data across these two. That's the main goal. So so we have finished it should have been done by now. Reset simulation. If I check the MAC address table, yeah, it has all the information. So now let's do one thing. Let's clear, okay. I hope this command works. So we'll have to see. So clear MAC address table. So we have to, let's see how we can do it. Clear MAC address table. Maybe we should go to enable mode. Enable. Yeah, so we are able to clear the MAC address table now. Yeah, show MAC address table, nothing is there. So we have deleted the MAC address table. And we have, let's get rid of this. So we have deleted the MAC address table, but we have in our, let's say PC1, if I check, it knows the MAC address and IP address of PC2. So it's like the previous switch was damaged due to some reason. We brought a new switch and connected them. All these PCs know about each other, but this switch does not know. So its MAC address is empty. What happens now if PC1 connects to PC2? So let's do this. So PC1 will connect to PC2. So we'll have command prompt again. We'll do it only one time. PC1 will connect to PC2. And we are running simulation mode. An ICMP packet is generated. Now what happens? There is no ARP because ARP process is not required, because in its ARP table or ARP cache, it knows the MAC address of PC2. So it reaches here. Okay, let's see. So source address is this, destination address is given. It reaches the switch. Next, what happens? The switch floods. The switch floods the packet to all three PCs. Why? Because its MAC address is empty, it does not know where to send. The switch only forwards packets with the help of or is the knowledge of MAC addresses. If you do not know the MAC address of a particular PC and which port it is connected to, the switch will flood it to all the ports. So this is another, you can say, broadcasting problem. So if a new host is added to the network of which the switch does not have any information about, it will flood in all its ports apart from the incoming port. So we want to stop this behavior, hence we need to create some VLANs or virtual LANs. So if you look here, what the switch did, this device, okay, yeah, okay. Yeah, it's fine. So the switch has, even though it knew that, uh, the destination address was present in the Ethernet, what is called layer to, uh, in the layer to the destination, source and destination addresses were there. The switch still flooded it because its MAC address table was empty. And now when it gets response from the particular PC2, it will learn about the MAC addresses. So this is what it is. You can again play around with it and clear your concepts by maybe creating more scenarios like this. So we'll now discuss about VLANs and how to get rid of this issue. So let's reset the simulation, go to real time. So the switch has, as you can see, if you click here, all the links are up. It is connected to all the 4 PCs, and it is given a VLAN ID also. If you notice here, all of these links, fast Ethernet 01112131, is given a VLAN 1. This is also called the native VLAN. So what we'll do now is we'll create another VLAN. Nothing has to be done on these PCs. These PCs have nothing to do. These PCs are unaware of this entire process. It is a switch which will intelligently forward messages and data frames based on its VLAN configuration. So let's try to put these two in VLAN 1. We don't have to do anything here, but we have to put these two in, let's say, VLAN 2. If you want, you can give put this in any random VLAN, but I am not going to do that exercise. You can do it yourself. I will put these two in another VLAN. Okay, so how do I do that? As I said, nothing has to be done to these two PCs. What we have to do is we have to give some intelligence to these ports of the switch. So we'll do that. So we know this is, so we'll first go to the command CLI mode, the command prompt mode, command line interface. So we have already, if you want to exit, you have to enter the root, you have to press enable. Then you have to configure terminal. You enter the configuration mode where you are able to change things. So let's now configure this. Let's now configure this in VLAN 2 and this also in VLAN 2. So we will do interface, find interface FA2/1. We enter that. Then you can simply Google how to create a VLAN for. If you even I don't remember all these commands, but if you practice once or twice, it will come to you. It's not very difficult. These commands are quite easy. So I have entered this interface. Now I can make this what is called tag this interface with a VLAN ID. Okay, apart from one, which is a native VLAN. So for example, here there is a very good blog. There is a packetlife.net I found. It's a very good blog. There are different cheat sheets here. Basically, it is telling you there's different posters uh, of important protocols and so on. And one of them I found, this is VLAN. It's a very easy to, it's a very simple poster where it gives almost all the information you need to create a VLAN and configure a VLAN. So we'll do this. So for example, here we have entered this. I think I have downloaded this as well. Anyhow, we'll see what to do. Okay, so we have this. Downloaded this. We'll use that. You can simply Google also. There are many websites like that. This is the one I found. So in downloads, I have found this. So let's keep this in hand as we do this task. We'll keep it on always on top. So this interface F2/1, let's give it a VLAN name. Let's make it VLAN 2. If you want, you can give it a name. Maybe the department name, you can name it. I am not interested. No requirement in my opinion. Now, these ports that are there, which are connected directly to these devices, we call them generally access ports. There are other type of port. There's another type of port which we call trunk port. We'll talk about them later. But these ports are called access ports, which are directly connected to some computing device. Generally, this will have low bandwidth because these are computing devices. If, for example, this switch is connected to another switch and we need to do some inter-VLAN routing, we'll talk about that. Then we need to configure the port that is connected to another switch as a trunk port. We'll talk about that. But let's now finish this. So we have created a VLAN in this switch, but we have not assigned any port to it. So we will do. So we'll just simply copy this. Okay, maybe I can switch port. Mode access. Okay. Oh, before we do that, we have to enter. We have to enter the interface of FA2/1. So I forgot almost. Let's interface FA2/1. Now we have to do it. IF means interface. Obviously, VLAN, you understand what it is. So switch port mode access. This is an access port. Generally, you don't have to specify this. All ports in a switch are generally access ports, but we are just doing this. Then we'll do some non-negotiated the switch port non-negotiated. Basically, what it means that we are going to statically manually configure all this. We don't want any other software to do it for us and interfere in this process. Okay, so we will do switch port not non-negotiate, it is no negotiate. Then which port access VLAN 2. That's it. This port VF2x1 has been configured with VLAN 2. Let's see. See, now you can see there is a VLAN 2 F2x1. So let's now repeat this same process for this F3x1 interface. So we'll enter interface. First we have to exit this interface FA 3x1. Fine. Now we will do switch port mode access, which is generally always there. Let's not do this again. So switch mode, will skip that part. No negotiate. So okay, interface FA, okay, it's still there. So okay, maybe we need this port mode access. Okay, which port no negotiate. Yeah, I think we need that, otherwise that is a issue. Then we'll put it which port access VLAN 2. Okay, let's do it. Now let's see what happens. See, fast Ethernet 2x1 and 3x1 are in VLAN 2. Fine, great. Now let's see how packets are forwarded. Okay, we'll keep this. We'll run simulation mode. We will try and first ping this person. Okay, PC1 to PC2. This is, let's see what its MAC address is. Show this MAC address table is empty. So we'll be able to find out if the ARP messages that we'll get, it will be flooded everywhere. Let's see. Okay, so let's keep this on top. Let's ping. Okay, let's do this. We'll ping first PC2. We should be able to ping it. Both are in the same VLAN. ICMP. Then it reaches the switch. It goes to the switch. No issue at all. Then return ICMP, reply. There was no ARP because we had already done this once. This guy knows the MAC address of this guy. So let's try this. So we'll reset the simulation. So you saw that there was no issue and there would not be any issue. But if I try PC1 to PC3, PC1 is VLAN 1, PC2 is in PC3 is in VLAN 2, so it should not be able to reach. Let's see what happens. ARP. It has never, PC1 has till now not pinged PC3. So ARP has to be initiated. Let's see what happens. It reaches the switch, but what has happened is it did not forward the packet in all three. You see, in the ARP, when it reached the switch, all destination was FFF because it's trying to learn the MAC address. But because this is in VLAN 1, the switch will only forward this ARP message to those computers which are also in VLAN 1. It will not send the broadcast message to other computers. This is what happened. So obviously the switch will not be able to learn about the MAC address of PC3 and PC4. If I look at the MAC address table now, the switch only knows MAC addresses and interfaces of this, and it is in VLAN 1. So let's stop this simulation. You understood what is going to happen now. But you saw that PC1, first of all, can never ping PC3. It's impossible. Even if its ARP cache was full, it knew the IP address of PC3, it will not be able to ping. The switch will not allow it to transfer any packets to PC3 or PC4 because it is in different VLAN. So now try something, let's try something different. So let's go to PC3. And now let's try to ping 10.1.1.4 from here to here. Because I think PC3 also, let's check its ARP. Oh, it knows because we have done it once. Does PC4 know? Yeah, it will be knowing, I guess. It also knows. So you get the idea what's going to happen. But let's try PC4 to PC1 now. Okay, PC4 to PC1, just for the sake of, let's say ping 10.1.1. Let's just, for the sake of fun, let's see what happens. PC4 does not know the location of this PC. What is its MAC address? So ARP is flooded once, but it is in VLAN 2. PC4 it is in VLAN 2. So even if the ARP is flooded with broadcast address in the Ethernet layer or the layer to data link layer, it cannot forward packets to, or it does not forward packets to all the devices, only the devices which are in its own VLAN. Again, we see that there is no way for PC4 to ping PC1 or PC2. Similarly, nobody here can transmit any data to these two PCs. The only exception in this is there is something called, you see, PC1 and PC2 are in, sorry, VLAN 1. This VLAN 1 is also called native VLAN. And this native VLAN, it is accessible to something called management traffic. This, when you have a big network, lots of switches are connected to it, and those switches are connected to routers and so on and on. These switches need to continuously connect to each other, knowing that are you okay, are you able to transmit and all that, to manage this network. This is called management traffic. There are different protocols for doing so. And those traffic are always in this native VLAN, or generally it is VLAN 1. Those traffic, they are able to go through any VLAN. Those traffic can access any VLAN. So those are special cases, but otherwise it's not possible. So this is how, okay, so let's reset the simulation. We see that now we have created from this physical topology of a star you've created divided this physical topology of a switch basically into two switches, basically two unconnected switches. It's as if there is one switch which is connected to PC1 and PC2, and there is another switch connected to PC3 and PC4, and there is no interconnection possible between them. Those two switches are also not connected. That is called, let's say, the logical representation. So it's like you have here two devices representing these two, another two. I'm just showing this for the sake of illustration. Let's say network devices, switches. Let's pick any switch. It's like this physical topology has been converted into this logical topology. This is the logical topology currently. This physical topology has been converted into this logical topology. So now let's do a little bit more complicated, a little bit more